Welcome to the channel. So from this video we're going to talk about the quantum chemistry, how the quantum theories help in chemistry to recognize the beauty of chemistry. So there were many observations which had been taken around 19th century, which were the basis of quantum mechanics and the quantum theory. So one of the important observation was two slit experiment. First of all, we will see the observation for particles. For particles. Okay, let's suppose I have a screen here, right? And we have two slits. Let's suppose this is slit 1 and this is slit 2. Slit 2. Just assume both the slit have equal gap between them, right? Equal gap. Okay, so these are two slits. So as a particle we are using a gun as a source of bullet, right? So what happened, let's suppose if we assume that only slit 1 is open but not slit 2. Slit 2 is really close, right? So we can even count each bullet which can come from this gun, right? So when slit 1 is open, most of the bullet will going to hit the screen right in the middle. Let's suppose these are the portion where bullet hits, right? Most of the bullet can be distracted by these edges, right? And we can see some bullets here and there also, right? Like this. But most of the bullet you will see here. So we can just find the intensity of how many bullets arrive at this location. You will see that in the middle there would be more number of bullets. So we can just plot a rough diagram. It would look like this, right? Let's suppose this is the intensity curve when only slit 1 is open. I will recognize it with I1, intensity 1, right? Again, if only slit 1 is closed and when I just open slit 2, when again we can see the similar pattern, because when slit 2 is open, again most of the bullet will hit around the middle like this, and again few can be distracted and deflected here and there. We can again see when only slit 2 is open, then the intensity curve look like this, right? Most of the bullet will hit in this area. This is I2. But what happen when both the slits are open? We can easily say that the intensity would go like I1 2 would be equals to I1 plus I2, right? I1 plus I2, and the intensity curve would look like this. Rough diagram, but I hope you can understand. So more of the intensity will be just in the front of this slit, and few intensity will come in the center of the screen, right? So this is the nature when we do the two slit experiment for particles. Here as particle we use bullets. So you know that particles have a property that we can count, right? We can count like there's a one bullet, two bullet. It cannot be 1.5 or 1.2, right? So this is the discrete nature. Discrete nature of particle. As we can count it in a whole number, 1, 2, 3, and 4. It cannot be in the decimal, right? So this curve is I12 when both the slits are open. So we have also done this experiment for waves. Let's suppose water wave. So for waves, I got this figure from a very famous book, In Search of Schrodinger Cat, by Jones Gribbin. So what they were saying, let's suppose we have a source here, source of wave. So let's suppose if there's a huge pond, right, or river, you can assume, and you just throw some stone, and you will see some kind of waves, right, which is running toward the screen. So how much height the waves will take, let's suppose this is the maximum height a wave can take of water wave, and again it can go down and so on, right? So that maximum height, you just feel it uniform, right? The maximum height which is achieved is, let's suppose, the displacement, or you can say amplitude. So more is the displacement, more would be the intensity of the wave, right? So we can just write that intensity, oh, intensity means how much number of wave arrives at a particular point. So intensity would be directly proportional to displacement square. Displacement square. Sorry. Displacement square. And here the displacement, I am writing it like psi. Psi just denote the displacement, how much wave it displaced from the initial point. So intensity would be directly proportional to displacement square, psi square. So let's suppose when only slit 1 is open, you can see the waves like this, and here in the middle we have more density or intensity of wave, and when slit 1 is open, you can see the similar curve will come, right? And when slit 2 is open, you will see the similar curve is come. But when both the slits are open, then we can see here interferences occur, like constructive interference, which actually increases the intensity in just the middle of this whole screen. So the I12, when both the slits are open, the curve would look like this. In the middle we will see the high density or intensity of waves. So this basically tells the maximum displacement occur at the middle portion of the screen, more intensity. And here where the intensities were less, it might be possible due to destructive interference. But here we cannot say like I12 is equals to I1 plus I2, right? If I just wanted to find out I1, what we can write? I1 is proportional to psi 1, right? Psi 1 square. Even I2 is also proportional to psi 2 square. What psi 1 tells us? Psi 1 is basically the contribution of the wave function. Contribution of wave function from the waves comes from slit 1. Similarly, psi 2 resembles the contribution of the waves which come from the slit 2, from slit 2. Fine. So but what happened to psi 1 2? Psi 1 2 would be psi 1 plus psi 2, right? Because these are wave functions. So the intensity I12 would be equals to, or would be proportional, that is more better thing, it would be proportional to psi 1 2 whole square, right? So even if I just talk about the electrons, what happen to the pattern of the electrons when we have a beam of electron. So nowadays the techniques are so advanced that we can even count each one electron which is arrived at a point. So it means we can count the electrons. They have some kind of particle nature. So if they have particle nature, they should show this kind of uh, curve when both the slits are open. But this is not true, because for electron we actually see this type of curve, this type of pattern is come even for the electron. It means we can count each electrons because they might have particle nature, as well as they are showing some kind of wave nature, right? It means electrons have both the natures. Even very famous scientist de Broglie suggested that any matter any moving matter any moving matter have dual nature. Any moving matter, even every moving matter have a dual nature. So particle nature as well as wave nature. This is true for any moving object. Example: electrons, photons, light, or you can say protons also, helium atom, even C60 molecule, etc. So this thing, de Broglie suggested that every matter have a dual nature, particle as well as wave nature. So in the next video we will talk about the de Broglie bit, and how the uncertainty principle come and what it suggests. Basically we're going to discuss in the next video. Thank you for watching the video.